Welcome. In this session on natural deduction, we'll begin our exploration of what we mean by scope and binding. Let's start by saying that the scope of a quantifier is, and we'll put this in quotes because we will actually work this out in more detail. The scope of a quantifier is what it applies to. And let's start with a simple example. Let's say that what we want to do is we have an example where we have three predicates. So let's suppose that a predicate is P and a second predicate is Q, and then let's suppose that our third predicate has two variables. Let's look at this formula. For all x, P of x implies Q of x, and S of x, y. Let's try writing out the parse tree for this. So we would begin with for all x. Good. And then we parse this and we see that it's got the form of a conjunction. So we make a conjunction, then the next node. The left conjunct is P implies Q. So that's an implication. And the antecedent is a predicate. And underneath that is the variable x. The consequent is a predicate. And underneath that is the variable x. And then the right conjunct is a predicate. And underneath that are its two variables. And let's write this variable in a different color because there's something special about it. What we mean by the scope of a quantifier is what it applies to. So for example, here, the scope of the for all x is every x in the parse tree underneath it. So here as we go down, we see that that x is within the parse tree, and that x is within the parse tree, and that x is within the parse tree. What we observe is that this y is not in the parse tree of this for x. And indeed, there doesn't seem to be any quantifier that applies to that y. What we'll do in a later session is we'll define all of these x's as being bound variables, and we'll call y a free variable. Let's note that is that x here is bound by that for all x, and let's write that y is free. That is, y seems to be unspecified in this formula. And it's not exactly unspecified, that is, y appears. But there's something a little unusual about the appearance of y there. Let's look at a second example. Now, let's take this conjunction and let's make the left disjunct this quantified part and the right disjunct just this formula. So let's look at for all x, if x is P, then x is Q. And now let's take that, let's put some big parentheses there, and S of x, y. So now let's write the parse tree for that. And when we do that, we see that the structure of this formula is a conjunction, and the left disjunct is a quantifier. And underneath that quantifier is an implication. the antecedent of the implication is a predicate of x, and the consequent is a predicate of x, and the right conjunct is a predicate, and it is of two variables. And now let's switch and let's put x and y here. The reason for this is now we will use this idea of what does it apply to. As we come down here, when we go down the left branch of the parse tree, we see this quantifier, and we can see that underneath this appears both of these x's. So what this will mean, and we'll explore this in a little more detail in a later session, what that means is that the x's underneath this part of the parse tree have to be the same x. And over here, we have this predicate, and now neither x nor y appear underneath a quantifier. And so here, what we'll do is we will say that these two x's are bound, and that this x and this y are free. So what we'll say is that these x's are within the scope of a quantifier, and it is not true that this x and this y are within the scope of a quantifier.